In the last chapter, we saw where AI lives in 6G. Now, let's answer the critical question. How does this make 6G fundamentally different from 5G? The difference is between AI enabled and AI native. 5G is AI enabled. Think of it as using a powerful separate tool on top of the network to improve performance. It's a great optimizing strategy. 6G is AI native. It is built inside every layer, making autonomous decisions across the entire system. In essence, AI-enabled 5G optimizes the network. AI-native 6G redefines it as an intelligent, evolving entity. Beyond philosophy, the technical limits are staggering. Speed, while 5G peaks around 20 gigabits per second, 6G targets speeds of 100 gigabit up to 1 terabit per second. That's a huge increase. Responsiveness, that is, latency. 5G's latency is fast, around 4 to 10 milliseconds, but 6G aims for the frontier of real time, 0.1 to 1 millisecond. This ultra low latency is key to enabling seamless, safety critical applications like complex robot surgery or instantly controlling a fleet of drones remotely. Intelligence and awareness. 5G has only limited sensing capabilities, but 6G will feature fully integrated, far more sophisticated sensing abilities using integrated sensing and communication, or ISAC. This means the network doesn't just connect devices, it sees the world around it, turning base stations into massive distributed sensor arrays. Efficiency in communication. This is a massive paradigm shift. 5G sends the raw video bits, bit by bit, even if most of the bits are redundant. Thanks to AI, 6G introduced semantic communication. It sends the meaning. For a security camera, that means only sending the message. Intruder detected at the front door, rather than streaming an 4K video feed. This achieves unprecedented data and energy efficiency. Speaking of energy, AI native 6G is designed from the ground up to achieve massive gains in energy efficiency per bit compared to 5G, crucial for a truly sustainable digital future. In a 5G network, human engineers lead the operation and management, using AI only as an assistant. In AI native 6G, the roles are flipped. AI leads the network's operation and management, handling day-to-day decisions autonomously. Humans step back to supervise and set high-level policy goals. This autonomous intelligence unlocks truly revolutionary applications, such as large-scale real-time holograms and comprehensive predictive digital twins of entire cities. As you can see, the shift is enormous. Now that we understand the power of 6G, let's look at the hurdles. In the coming chapter, we will dive into the serious challenge ahead for 6G deployment. We will be diving into those incredible new capabilities in a future video. For now, let's turn our attention to the hurdles. 6G looks unstoppable on paper, but here is the cold, hard truth. We are nowhere near ready. There are some robots between us and that glorious future. Challenge 1, the energy monster. Despite being vastly more efficient per bit, the total energy use of an AI native 6G network is massive. Why? All that consistent processing, all the real time AI modeling, and the sheer density of the infrastructure are incredibly energy hungry. If left unchecked, the energy cost of running 6G would skyrocket, making network operations unsustainable and dramatically raising consumer prices. Solving this requires AI to become its own primary energy optimizer. Challenge 2: Privacy and regulatory conflict. 6G's revolutionary features, like integrated sensing and communication (ISAC) and persistent digital twins, require constant environmental scanning, including tracking human movement and even physical status. This creates massive new policy risks and immediate regulatory conflicts. How do we build a network that constantly sees people without violating fundamental data rights like the GDPR? This is a policy problem we must solve now. Challenge 3: Fermentation of global standards. Currently, we lack a unified global standard for 6G. Countries and regions like the US, the EU, China, Japan, and Korea are all pushing different visions. There is no common agreement yet on the terahertz bands to use, the core level architecture, the AI model interface, or even the security frameworks. This geopolitical fragmentation risks creating multiple incompatible 6G versions globally. Challenge 4: The talent and skills gap. Managing an AI native network requires skills that are incredibly rare. Telecom teams typically lack the deep AI and machine learning expertise needed to maintain these systems. On the flip side, AI teams often lack wireless expertise. Industry estimates predict a serious shortage of specialists with both AI and wireless knowledge by 2030. Training this new generation of engineers is a huge task. Ultimately, realizing AI native 6G means succeeding on four fronts: making it secure and affordable, ensuring it is energy efficient and globally interoperable, and guaranteeing it is socially and ethically acceptable by the time of widespread deployment. Although there are challenges ahead, the AI native 6G revolution is already underway. Industry giants are not waiting for the standard. They are building the future right now. On October 28, 2025, NVIDIA CEO Jensen Huang announced a $1 billion equity investment in Nokia. This partnership is designed to accelerate the development and deployment of AI native mobile networks and AI networking infrastructure. And they are not alone. US operator T-Mobile has already committed to working with Nokia and Nvidia to test these new AI RAN technologies in their 6G development efforts. Additionally, Dell Technologies is providing its powerful Power Edge servers to run the intensive AI workloads required for the new network. Across the group, similar strategic projects are in full swing. Samsung has launched a dedicated AI RAN app and is working with carriers like KT, SoftBank, and KDDI Research. Ericsson has opened a new 6G lab in Budapest and a new R&D unit in India to drive 6G research. Major Chinese vendors, Huawei and ZTE, are also heavily invested in 6G and AI-enabled technologies, with a particular focus on how AI can optimize network performance, spectrum efficiency, and data management within their extensive research programs. Crucially, alliances like the AI RAN Alliance, the North American 6G Alliance, and Europe's 6GIA, the 6G Smart Networks and Services Industry Association, are working together to ensure global standards ultimately emerge. So, when you see this, the development follows a clear path. We have just passed the vision and requirements definition phase. We are now in technical studies and pre-standardization. The critical standardization phase runs from 2027 to 2029, leading directly into trials, evaluation, and commercialization, starting around 2029 and expanding into the 2030s. Of course, timelines are flexible. Geopolitics, spectrum fights, and talent wars could affect the schedule, but the train has already left the station. In the end, AI native 6G is not hype. It is the moment networks stop being dumb pipes and start being smarter than us. Faster? Sure. More connected? Absolutely. But truly, it is a living, evolving brain that sends the world, understand your intent, and deliver magic. From holograms in your kitchen to robots running factories flawlessly. We have seen why companies like Nvidia and Nokia are investing early. They are shaping the intelligent networks of the future. Next time, we will discuss the mind-blowing applications of 6G empowered by AI, including holographic communication and digital twins. Do you have any ideas about how AI native 6G will change your life? Let me know in the comments below. If you want to stay ahead of these technologies, remember to like and subscribe because the 6G revolution is closer than you think.